Welcome back. This is lesson 8.5, Journal Modeling Multiplication Equations. I will be able to model multiplication equations using algebra tiles. I will be able to make an accurate representation of each equation and show my work mathematically. Okay, equation for this lesson, vocabulary for this lesson. Equation is when we mathematically have a mathematical statement that two expressions are equal to each other. Solution is a value that makes a variable true for an equation. And inverse operations are operations that undo each other. Addition and subtraction are inverse operations of each other, and multiplication and division are inverse of each other. So I want you to think, once again, of the equal sign as the fulcrum of a balanced scale. What is on one side must balance exactly what is on the other side. Okay? Just a reminder, we use long rectangles to represent the variables. I'm going to use X, but it could be any letter. And we use little squares to represent 1. So, if I'm going to model 2x, on this side of the balance we have 2 x's. On this side we have 12 little squares. Okay, so on one side 2 x's, the other side I have 12 squares. Now, I'm interested in what 1x is worth. I know that 2 of them are worth 12. So to figure out what 1 is worth, this is multiplication. I have 2 groups of this. So what do I do to undo multiplication? Division. So I'm going to divide it into groups so that I have 1x in each group. Well, if I'm going to make 1x in each group, I'm going to divide it here. Here's one group, 2 groups. So what I just did is I divided it by 2. Now when I take 2 and I divide it by 2, what's 2 divided by 2? 1. I get 1x. Now do I have to write 1x? I can, it doesn't hurt anything. But 1x is the same as just x, isn't it? Okay, I divided this into 2 groups. To keep it balanced, I'm going to divide this into 2 groups as well. So, divide this into 2 groups. I divide 12 into 2 groups. There would be 6 in each group, so there's 1 group, 2 groups. So in other words, each x is equal to one of these groups. So if I divide 12 by 2, I get 6. So I'm saying that I think each x is worth 6. How do I prove it? I plug it back in to x. So my original equation was 2x, so I'm going to put 2 times 6, and I'm going to see if I get 12. Well, if you know your times tables, you know that 2 times 12 is, or 2 times 6 is 12. That matches, and we know that this is correct. So 1x is worth 6. Now, I know that your brain is screaming at you again, this is so easy, why do I have to write all this stuff out? I'm trying to teach you methods that, with easy numbers now that are easy to draw, easy to see, it makes a difference to get you the skills and the practice so that when you come to harder numbers, you already know the process to take so that you can figure out any amount. Okay? So yes, I know that your brain was probably saying, I know it's 6, why do I have to do this? I'm trying to teach you a method, not necessarily that x is 6. Okay, let's try this one. 5r equals 15. If I have 5 r's, that means I'm going to draw 5 rectangles. So 1, 2, 3, 4, and I'm running out of space on this side, so there's 5. Each one of these represents R, so there's my 5 R's. 5 R's is worth 15 squares, so I'm going to draw 15 squares over here. Okay, I have 15 squares, 5 R's. Now, if I want R by itself, meaning I want one R, not 5 of them, I'm going to split 5 R's into 5 groups. One group with 1 R, one group with 1 R. I just divided by 5. So over here, right, divide by 5. Well, 5 divided by 5 gives me 1 R in each group. 1 R is just the same as R, but in order to do that, I have to do the same to both sides. So I'm going to divide this side by 5 as well. So I'm going to make 5 groups out of 15. That would put 3 in each group. So there's 1 group, 2 groups, 3 groups, 4 groups, and 5 equal groups. So each R goes with one of these groups. That would be over there. So each one of those ties with one of those groups. So R is equal to 3. 15 divided by 3 is 3. You can see my work. You can see my drawing. Let's prove that it works mathematically by plugging it back in. 5 times R, which is 3, should equal 15. I know my times tables, and 5 times 3 is 15. Those are equal to each other. Okay, let's try the next one. Model 6 equals 3F. So that means I got 6 squares on this side. And 3 F's over here. 1, 2, 3. 3 F's equals 6. So if I want F by itself, I need to make 1 F in each group. So I'm going to divide by 3. 3 divided by 3 is 1, so that'd give me 1 F, or 1 F in each group. So 3 groups, 1 group, 2 groups, 3 groups. So if I split that into 3 groups, I also have to split this into 3 groups. 6 divided by 3 is 2, so that puts 2 of these squares in each group. If I put 2 squares in each group, then I know that each F is worth 2. So 6 divided by 3 is 2. Plug it in and check. 6 equals 3 times, we say F is worth 2. 3 times 2 is 6. That tells me I'm absolutely correct. Now remember, this is about learning the process. Not that you couldn't figure this out on your own, because yes, these are simple numbers. I'm teaching you a process. I did the same to both sides. I did the opposite of what's happening. I did the opposite of multiplication, which is division. And you can see over here that each F is worth 2. Okay, last one, 18 squares. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares. And on this side, 6 M's. So 1, 2, 3, 4, 5, and I'm running out of space, so 6 goes up here. Each of these is an M. Okay. So I have 6 M's equals 18, but I want 1 M, not 6 M. So I'm going to split this into 6 groups, divided by 6. So if I divide this into 6 groups, there's 1 M in each group. That means I have to split this into 6 groups as well. So 6m split into 6 groups puts 1m in each group. If I split 18 into 6 groups, that puts 3 squares in each group. 6 equal groups. So each m is worth 3. So m equals 3. That's what I think it is. Plug it in and check. 18 equals 6 times 3. I know that 6 times 3 is 18, so yes, this is a true statement. Okay, rate yourself on this concept. How do you feel about making models of simple equations and showing your mathematical work and checking them? 0, 1, 2, 3, and 4, take a picture, turn it in on Google Classroom.